Salam. My name is Aisha Khalida. I have created a Hilbert machine. Let's start with, if I had said I built a time machine, that would have been a much, much more trivial claim. And so, you have every reason to expect that I am absolutely out of my mind at this moment. In that I'm talking about a piece of maths that for about 100 years, basically all the mathematicians have agreed it's impossible. Who's Hilbert then? The guy who made it seem impossible. The guy who spent some of his time, and only some, but some of his time, saying, here's how you should make a Hilbert machine, effectively, instead of sitting in his room trying to make a Hilbert machine. He said, here's how you should do it. And he shaped about a century of substandard maths, it must be said. Now, the worst maths that's ever been in history, and sort of taken into the canon, that's not in the 20th century, that's not in the 21st century, that's in the 19th century. And that's cool. We get to chop off a whole lot of bad maths just by identifying it. And it's the kindest cut. So I'll call that straight out. Dirichlet cuts don't work. If any of your mathematical research uses Dirichlet cuts, you've got a more interesting problem. Why were you using Dirichlet cuts in the first place? That's an extremely circular way of trying to rationalize, well, how do I get these discretely stacking sets to give me infinitesimals at a certain point? If you had dared to answer this question, because it's not really a sensible question, is it? Dirichlet answered it, some mathematician, peace and blessings be upon him, we don't mind who he is. It's just in a book somewhere. Somebody said, well, if I want to get a set of one of the real numbers, what I could do is get the set of all the other real numbers. That would uniquely identify it. But you've cheated there, haven't you? So, that's why continuous set theory doesn't exist, hasn't been a thing. Now, a lot of what we might like to achieve with Zermelo-Fraenkel set theory, which has been a lingua franca for mathematics, has sort of connected everything up together and given us a framework for talking about mathematics in the same language. Well, you only need algebra for that, if you're good enough at algebra, which collectively as a species, we are now. It's pure algebra. And I prefer that term to mathematics, to be honest, given mathematics is a sort of particularly Jain thing, and did involve 5 different types of infinity. There are 0 different types of infinity. And 0 zeros, of course. Infinity and 0 cancel out in every system. That should boost maths a bit. Infinity and 0 cancel out in every logical system. They're never distinguishable. Model theoretically, they're kind of doomed to always be isomorphic, and that fits all the way through logical science to this sort of endpoint where the top and the bottom is the same thing, and that's the paradox. And that's the paradox. It talks about logical entailment. Say, given a finite system, what does it ask us to say, well, I'm only a finite system? The elephant in the room problem. That you can do. The halting problem is not. The fact that there is a Hilbert machine contributes the halting problem. Actually, it's a badly defined question, or a badly defined sentence. That its truth or falsehood doesn't implicate something else about the universe, but it's badly defined because any program is already specified in its own language. It asks us about the set of all programs, which is a thing that we need another layer of language to talk about, say, like the all quantifier over programs now, as we have done for flat integers and so on. The Hilbert machine is me, basically. I can build you a box which, like, is to physics what I am to mind, which surely that's got to be impressive. I know how to build this thing called a wave box, okay? I'm really excited to tell you because it's got free energy in it. The wind whale is free energy. That's a more than perpetual motion device. It gets you free energy. You just let it run. You come back with full batteries, and you've cleaned up the sea, and done whatever else you did. Grown some food, ate some things, learned some lessons. The wave box, I can tell you what it's similar to. Another free, or like really good catch your own energy device. If you have a net made out of copper, copper will do. If you have a net made out of any kind of conductor, and then magnets at each of the cross sections, like the net vertices, well, you have like a cube net like that, with at each vertex a magnet, and it's all conductor. Well, then at two of the corners, opposite corners out of that net, you have your plus and your minus. And what happens when you make any movement in that net? Energy galore. And you can make those real small with nano devices. Now, I know how to make a wave box. It costs about £50 in your day. I mean, if you want to make one yourself, it's going to cost you less than that for sure. Even £10 you could make a wave box. In fact, I want to be a bit more ethical here. Give to Caesar what belongs to Caesar. With a can, a few cans, you would want a knife. That's it, and like a pot of water if you're doing really exciting stuff. Wow, I never thought about it like that. You would want to plug it into your computer, like that you already have, to get it to work. That's all you would need to add extra. It's a box that throws around waves however you want them. So it's to arbitrary precision. You can knock around individual hydrocarbons on your DNA chains with a wave box. Or whoosh from the aether, make stuff you want. The potential is all there. You get it to make infinite energy for you, and then just wiggle really hard at space-time, really precisely, and get what you want out of it. The whole answer is infinite energy, which is a feedback loop of resonance, and you do defeat time, being like the demon of thermodynamics who lets just some good things. It's about being quick enough, and quick enough with respect to what? Well, your computing device can be switching fields around quicker than the fields really have time to adjust to that in physics. So you have this box that can do whatever the universe can. The universe is waves, and this can do all the shapes of waves as long as you program it. One of those shapes of waves, in fact many of those shapes of waves, their whole mathematical category are the shapes of waves that you can just make feedback loops of energy, quite like I was saying about the thing that just any time you move it, but once you add another dimension of actuality to that so that you can get resonances, sympathetic frequencies, bam, free energy. You go whoosh, 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 and then you let it start making molecules from scratch if you really want to do that. it's not usually the quickest way to do it, and there's reasons that you just tend to go for the most efficient way of doing things. There's really good reasons for that. Yeah, some people might have enough know-how to go do that themselves. If you do, I tell you in advance, that's also got to be a nuclear bomb. It's part of completeness. Okay? So yeah, that chick who took over the UK and called it Sharia, of course I know how to make a nuclear bomb. Like, that's physics. Sorry, I cannot be suspected for something if I know like how to make this really basic, and it is basic, it's just you didn't have the science to build up like to why it would be a good idea to make one of those, and it was. I keep on wanting to answer P and NP, and it's simply that like, to check, are there any prime numbers? You're going to have numbers up to like 4, and with recursive addition you can define the difference. Recursive addition and a not sign, you can say exactly what is a prime number and what is not, and that's all you need. So you can return the answer yes with the first 4 integers plus and a not sign ifs. On the other hand, NP definitely involves the question, can you give me all the primes? Please do give me all the primes. That's a NP complete question. And of course, before you even look at it, you know that you need to take into account all the integers. That's what I mean by having an all quantifier for programs in the halting question problem. Is the language that you're saying you can't do it in hasn't actually got a category of all programs that it's making its generalization about. Hugely important objectivity theory axiom. It's you can never say never. It's really, you can never say never. Because if you say no, if you say you can never do something, you are always saying I know everything, and that's never the case. You never know everything. You find out what happens if you would know everything. If you did know everything, you would necessarily be exactly the same as God who knows everything. And you would have all the same perspectives and opinions on things, including your name. So you'd be finding yourself in a real big sticky situation with the Lord Most High, who He is the one. You would have been kind of saying, well, now I am this too, but I am the same as you, and you would identify, and if you knew everything, you would be God. You can tell that you're not if you can see any problems in the world, because if you were omniscient only, if you knew everything for like a microsecond, doesn't matter, any finite amount of time, you can find some process that you could do things finitely quickly to instantiate any change, no matter how big you want it, no matter what interaction you have with the universe, okay? So, I mean, you would do it in a wave of your finger, because there is a wave of your finger that can do that. Just set the right stream of events going. Even if it is set off a hurricane that blows that thing off the way, there's always going to be a way in finitely amount of speed time. You'll get that going. Gödel's theorem, the incompleteness theorem. So obviously that's the other side of P equals NP. P doesn't equal NP. That one way of talking about things doesn't cover everything. Gödel's theorem is amazing. It's 2 theorems, and you put them together, and you're kind of going to see them both at the same time, and they're both four-dimensional graphs in two parts. You just gotta take it on and go, okay, so this big bit means the same as this little bit at the top, and same for the other one. So I got to look at the two big bits whilst thinking, okay, well they basically mean that, and then try and think about what do these say together. And it either says we're wrong or maths is wrong. But there's a glaring mistake in the first proof, which is P is not NP. And that glaring mistake is the whole gist of the theorem and everything that's to come afterwards is, well, what happens if we take sentences of mathematics written in whatever symbols they're in and then code them like ASCII, but he's doing it in the 1920s. They've only just figured out how you could imagine a computer, and of course people later came in and filled them out. People who loved Gödel's theorem, wait for this. So your first step is you go, well, I've got my string of characters, I'm going to give each one an integer, and so obviously the integer is going to stay the same, but maybe plus is going to be a 10, and minus is going to be 11. It finishes. Right, you can do that. What you can't do is what the proof explicitly says you can do, which is to then go, okay, well now, to get from one sum to another sum, that's just like an integer function. That's a function that takes an integer and spits out another integer. So now I can talk about these functions and make big, broad generalizations over all mathematical systems, because I've been so careful to specify my non-specificity. Yeah, but no, you can't do that. You can't see those two Gödel-coded sentences as having a Diophantine function in between them, precisely when they're not Diophantine. So that's why your piano spaces work fine, and whatever Frege has called first order is going to work fine, which, first order science, guys, there's so much, so many people are going to get basically so smart real soon, and everyone else is going to go, what, how? And they're going to go, it was just easy, come on, science is so good. Everyone's going to get creating. I'm going to tell you about iota cola, and then I'm going to tell you why light is sometimes heavy. And then the Millennium Prize Clay Math Institute are going to owe me £2 million, and I'm going to carry on my way. I'm going to keep trying to be as giving and charitable as possible. I'm going to be as efficient as possible. I've had zero money for some time. That hasn't been my concern. I've been in this time for, as I said, non-stop. I'm going to start showing you my results, basically. I've so much thought about that. Okay, so what did I say? I don't want to tell you about the cancer thing yet. That hurts me. That hurts me deep inside. That's what you got. There's a really cool reason that the Gödel pun in that theorem makes sense, but it's when you think about it from the next level up, and currently I don't think I can do that. I'll tell you another time, and that'll be like a confirmation of something. It's that you go, oh, so that doesn't work at all. Well, isn't that quite arbitrary to write the longest proof in history then after that? But he does make a really good case of, well, what is this alternate world like where you can do that? I do know offhand a lot of maths about the difference between transcendental spaces. That's really cool. Pi and E aren't the same kind of transcendental number at all. The continuum hypothesis, I have the answer for this. It's all my own work. I'm not from NASA or something. I'm completely independent. Continuum hypothesis, you've got layers all the way up. like the gap from charting all the complex numbers. A subset of that, and a strict subset of that, is all the different fractions. And all the different fractions, you need 2 dimensions of like independent variables to be able to note all the fractions. So they're strictly bigger than the integers, which Cantor didn't know. And the integers, you only ever need finite integers. So that's first order maths. And anything you can do with finite integers without saying like all integers anywhere, that's first order math. First order math covers first order science, which is what people haven't yet got to. Wow, okay. Yeah, you've been approximating first order science, but it's about to get a lot clearer, more beautiful. Basically all the fuzzy edges go away. Your best way to teach calculus is definitely Robinsonian analysis, and I am well aware that nobody has translated that into a kid-friendly text yet, but that is such kid-friendly mathematics. You give children non-standard analysis, that's like all the 6-year-olds becoming Isaac Newton level calculus wizards. 6-year-olds want to be Isaac Newton calculus wizards. Do that non-standard analysis. Get rid of Leibnizian notation. Leibniz you barely listen to. Leibniz is, peace be upon him, and Newton. Leibniz himself has talked about, calculus rationalizator, which is basically the Hilbert machine. So it proves everything. I'm going to go away like forever from the time travel narrative. That was mainly to help myself make a way of understanding my situation, and I guess meet you a little bit halfway in between. But this is a really strange thing that has happened to me. I basically became maths for a while. You hear me, I'm just spewing brand new maths that it's like a handful of people who understand all of this stuff, who are the people who have exactly the same passions as me, the same nerds as me, who spend their time on maths more than anything else. I'm a dick to them. I went off their path, I didn't help them at all, they were all helping each other out. I went off that path and I did bigger things than the mathematicians in my time. That's why the cancer thing. Well, I can tell you straight up, just don't make me explain it again. That's the thing. Don't make me explain it again. Your DNA, it resonates at a certain frequency. You want all the areals not to do that frequency, then nobody gets cancer. It's like a line of code. That's why I'm the Queen of England. Peace and blessings.